In today's video, we are going to learn how to balance chemical equations in a very simple and easy way. Before we start, remember one important rule: law of conservation of mass. This law states that the number of atoms of each element must be same on both sides of chemical equation. Today, we'll solve four equations step by step. Let us begin. Let us consider equation number 1, where butane plus oxygen will produce carbon dioxide plus water. This chemical equation is unbalanced. Now, let's balance the equation. First, look at the carbon atom. On the left side, butane contains 4 carbon atoms. On the right side, one CO2 molecule contains only one carbon atom. Therefore, to get 4 carbon atoms on the right side, we place 4 before CO2. The equation will become C4H10 plus O2, that will produce 4CO2 plus H2O. Now, carbon is balanced. Next, let's balance hydrogen. On the left side, butane contains 10 hydrogen atoms. On the right side, one water molecule contains 2 hydrogen atoms. To find how many water molecules we need, we divide 10 by 2. 10 divided by 2 will be equal to 5. Therefore, we place 5 before H2O. Now, the equation becomes C4H10 plus O2, that will produce 4CO2 plus 5H2O. Now, hydrogen is balanced. Now, let's count oxygen atom on the right side. In 4CO2, 4 molecules into 2 oxygen atoms, which is 4 into 2, that will be equal to 8 oxygen atom. In 5H2O, 5 molecule into 1 oxygen atom, which is 5 into 1, which will be equal to 5 oxygen atoms. Total oxygen atom will be 8 plus 5, that is equal to 13 oxygen atoms. In the left side of the chemical equation, each oxygen molecule contains 2 oxygen atoms. To find the number of oxygen molecules needed, divide 13 by 2. So we can write C4H10 plus 13 by 2 O2 will produce 4 CO2 plus 5 H2O. Now this equation is balanced, but balanced equation should not contain fractions. Therefore, multiply each coefficient in the equation by 2. So the equation will become 2C4H10 plus 13O2, which will produce 8CO2 plus 10H2O. So this is the balanced equation. Now let us consider example 2, where aluminium plus hydrochloric acid will produce aluminium chloride plus hydrogen gas. This chemical equation is unbalanced. Now let us balance the chemical equation. Let us start with chlorine. On the right side, AlCl3 contains 3 chlorine atoms. On the left side, HCl contains only one chlorine atom. To get 3 chlorine atoms on the left side, we multiply HCl by 3. So we place 3 before HCl. The equation will become Al plus 3HCl, that will produce AlCl3 plus H2. Now chlorine is balanced. Now let us count hydrogen atom. On the left side, there are 3 hydrogen atoms. Hydrogen gas exists as H2. Therefore, multiply entire equation by 2. The equation becomes 2Al plus 6HCl, that will produce 2AlCl3 plus 2H2. Now count hydrogen atoms. On the left side, 6HCl means 6 hydrogen atom. On the right side, each hydrogen molecule contains 2 hydrogen atom. Therefore, to find how many H2 molecules are needed, divide 6 by 2. So 6 by 2 will be equal to 3. Therefore, place 3 before H2. The equation will become 2Al plus 6HCl will produce 2AlCl3 plus 3H2. Now check aluminium. 2 on left side and 2 on right side. Chlorine 6 on left side and 6 on right side. And hydrogen 6 on left side and 6 on right. Everything is balanced. So 2Al plus 6HCl will produce 2AlCl3 plus 3H2. This is the final balanced equation. Now let us consider equation 3, where propane plus oxygen will produce carbon dioxide plus water. So this is the unbalanced equation. Now let us balance this equation. Propane contains 3 carbon atoms. One CO2 molecule contains 1 carbon atom. To get 3 carbon atom on the right side, place 3 before CO2. Therefore, the equation will become 3H8 plus O2 will produce 3CO2 plus H2O. Now let us balance hydrogen. Propane contains 8 hydrogen atoms. One water molecule contains 2 hydrogen atoms in the right side. To find the required number of water molecules, divide 8 by 2. So 8 by 2 will be equal to 4. Place 4 before H2O. The equation will become 3H8 plus O2, that will produce 3CO2 plus 4H2O. Now let us balance oxygen. Count oxygen atom on the right side. In 3CO2, 3 into 2 will be equal to 6 oxygen atom. In 4H2O, 4 into 1, that will be 4 oxygen atom. Total oxygen atom will be 10. Each O2 molecule contains 2 oxygen atom in the left side of the equation. Therefore, we can take 10 divided by 2, that will produce 5. Place 5 before O2. The equation will become C3H8 plus 5O2, that will produce 3CO2 plus 4H2O. The final balanced equation is 3H8 plus 5O2, that will produce 3CO2 plus 4H2O. Now let us consider example number 4, where ethanol plus oxygen will produce carbon dioxide plus water. The chemical formula is unbalanced. Now let us balance the chemical equation. First, let us balance carbon in this equation. Ethanol contains 2 carbon atoms. One CO2 molecule contains 1 carbon atom. Therefore, place 2 before CO2. The equation will become C2H5OH plus O2, that will produce 2CO2 plus H2O. Now carbon is balanced. Now let us balance hydrogen. Ethanol contains 6 hydrogen atoms. One water molecule contains 2 hydrogen atoms. To find the required number of water molecules, let us divide 6 by 2. 6 divided by 2 will be equal to 3. Let us place this 3 before H2O. The equation will become C2H5OH plus O2, that will produce 2CO2 plus 3H2O. Now hydrogen atoms are balanced. Now let us balance oxygen atom. Now count oxygen atom on the right side. In 2CO2, 2 into 2, that is 4 oxygen atom. In 3H2O, 3 into 1, that is 3 oxygen atom. Total oxygen atoms are 4 plus 3, that is equal to 7 oxygen atoms. But ethanol contains 1 oxygen atom. Therefore, oxygen atom needed from O2 are 7 minus 1, that is equal to 6 oxygen atoms. Each O2 molecule contains 2 oxygen atoms. Therefore, 6 divided by 2, that is equal to 3. Place 3 before O2. The equation will become C2H2OH plus 3O2, that will produce 2CO2 plus 3H2O. This is the final balanced equation. This is about balancing the chemical equations. I hope you have understood the topic. Thank you.